it is false. So line 4 will evaluate the right-hand side. X is 5. 5 minus 2 is 3. And then we use 3 to update x. So x is going to be updated to a value of 3. And then we are all done. Yep.
So you can choose whatever number you want for x?
No. In this case, I have to pick a specific value so that I can trace the program. This is considered a test case. In other words, I'm just kind of testing the algorithm to see what it's doing. Okay. In certain algorithms, you have to start with certain known values to test it. In certain other algorithms, you don't do it. If I give you an assignment like this, I would give you specific values in X, so that you can trace the rest of the algorithm. All right. Yep.
So can you make it where an if statement leads into another if statement?
Absolutely. Absolutely. Now, what you're asking, or what you're suggesting, is a topic that is, okay, I have to remember where I am here, so I'm going to just open a new tab and keep it at this spot. And then back up to, oh, I guess I opened another window altogether. So what you're asking is actually what we call a nested statement. So as you can have a conditional statement inside another conditional statement. It's kind of like a folder within a folder. So once you look at it as a folder within a folder, it's not mysterious anymore. But yes, you can have nested constructs in statements, different type of statements. Assignment statements obviously cannot be nested because you cannot put an assignment statement within an assignment statement. Not in this class. In C, you can. Yeah, C is a very strange programming language. For efficiency's sake, you can have an assignment statement within an assignment statement. Because assignment in C is not a statement, it is actually considered an expression.
Okay.
So you can have an expression inside another expression inside another expression, and that's why it can be nested. But in this class, within the context of this class, we consider assignment a type of statement, so you cannot have a statement inside a statement.
Okay.
For assignments. All right. So let's go back to assignments. Oh, the other tab. The other. There we go. All right. So do we have any questions about this particular example at this point? And by the way, how do you express the fact that z is the maximum of x and y? Let me just use I just want you guys to think about it for now because we will talk about it much later. But I want you to kind of think about it. Okay. So in English, we say z is the maximum of x and y. Okay. I can give you an example. When x equals 2, y equals 3, then z should be what? Should be 3. Okay, that's right. When x is 5, y is 5, what should z be? The maximum of 5 and 5 is 5. Okay, so we know what that maximum means. Okay, in math, how do we express z being the maximum of x and y? Okay, I just want you to think about it. I don't need you to give me the exact answer at this point because, start thinking about it because this will come back a little bit later. Okay, we'll try to answer this question a little bit later. For a very important, reason. All right, so this is basically, conditional statement. So now we're moving on to logical operators. A logical operator is not a comparison operator. A comparison operator says, okay, on the left-hand side we have a value, on the right-hand side we have another value, We want to see whether it is true or false that one is greater than, less than, equal to, not equal to, greater than or equal to, less than or equal to the other side. Okay, and we all know that stuff already. Logical operators work on Boolean values. Okay, the left-hand side is true or false, the right-hand side is true or false. Combined through this operator, is it true or false? That is a logical operator. Or we should probably call it a Boolean operator as well. Well, let's sidetrack a little bit and talk about Boolean. Okay. What does that mean, Boolean? Okay, look at Wikipedia and you can know right away. All right, so we'll look up Boolean expression. But you can also look up the other types. The other one, which is Boolean algebra. We will do things on Boolean algebra in this case. In this class, I just won't call that Boolean algebra. Okay, and Boolean expression. Okay. In computer science, a Boolean expression is an expression in a programming language, such as pseudocode that we use in this class, C, C++, and all other programming languages, that produces a Boolean value when evaluated. That is one of true or false. In other words, we have been working with Boolean expressions all along. All of the comparator operators, okay, less than, greater than, equal to, and so on and so forth, they all give you a Boolean value when you evaluate, because it's either true or false. Okay, so that's what a Boolean value is. It's just true or false. It's just a fancy name for it. The reason why it has a fancy name of Boolean instead of true false, okay, has to do with the person who came up with Boolean algebra. So when you click on Boolean algebra, you will see that Boolean algebra was developed by George Boole in his book An Investigation of the Laws of Thought. Okay, so it's not even mathematics. They don't call it logic. It's really just the ability to work with values of true and false, and how to combine those things and think in a logical way. How many people have taken critical thinking or a early, basic philosophy class? Do they talk about Boolean stuff? No. Okay. When I took critical thinking, they talked about Boolean algebra. Just may not using that name, but nonetheless, it's working with values of true and false. Okay. So that's a little bit digression. For those of you who are interested, you can definitely look there. But we use Boolean operators or logical operators day in and day out. When was the last time you used the word and, A-N-D, in English? Do you use it today? Do you think you use it today? You may not remember, but do you think you use that word today?
Oh, yeah, sure.
What about the word or? What about that word but, B-U-T, but? Use that word too today, Those are all logical operators. So we are using all these operators without realizing it, because we actually think in that way too. Think of one application of the word and, which we call conjunction in this class. How do you use the word and?
Combine things. To combine things.
To combine two things, okay? So let's say you're going to McDonald's, okay? And they have a promotion going. And they say if you order, I'm just trying to come up with an example. If you order a Big Mac and a large drink in the same order, they'll give you an apple pie, which is the only thing I like about McDonald's. Okay? Okay, so so what is the meaning of the word and in this case? Okay, it means that you need to purchase, go ahead.
You need to have two conditional statements that are true before you can go on to the next step. So you have to have the fries and the Big Mac before you can get the apple pie.
Exactly, so you need to order both the fries and the Big Mac in order to qualify for that free apple pie. Okay, but what if I change that word and to or? Okay, which is basically saying, if you order a Big Mac or fries, then you can get the apple pie for free. Is it different? It's very different, isn't it? Go ahead.
It just basically means you can either complete one
Or both of them, very good. Okay, when we use the word or, exactly. So you have to be careful. When we use the word or by itself without using either, it is different from when we use it with either. Okay, when we use it with just by itself, it means if I order a Big Mac, I can get the apple pie. If I order fries, if I make one order of fries, I can get the apple pie. If I order both, should I get it too? Yeah. If the requirement is or, that means if I order both, hey, I will get my apple pie as well.
They give you 2 apple pies.
You order separately in that case.
It's like, how would you write that out? It's like,
How do you write that out?
how would I write out how, like, limiting?
If you want to limit because you're sick and tired of people coming in and just order one fry and then come in again and order another Big Mac, you can place a condition of on the same day. Limited to 1 per day or limited to 1 per customer. Yep.
It's like
Then you need a surveillance camera and share images of customers across all the different McDonald's. Because guess what? I'm going to drive to the next McDonald's and order another fry and get another apple pie.
That's a whole other program. That sounds like something they have in Japan. Those smile
no,
monitors.
it's already happening. Okay, with Picasa, they already have a facial recognition. How many people know that? Okay, with Picasa from Google. So what you can do is you can take, you can upload like 20 pictures of grandma. Okay. And then in each picture, you say, this is grandma, this is grandma, this is also grandma, this is grandma, and grandma, okay? And then Google can use all those images and start to generalize and try to pick up all the facial features of grandma. And then after that, you upload 6,000 pictures of family reunion and whatnot, okay, trips and whatnot, okay? So what you can do next is to say, find all pictures with grandma in it. It will go through the 6,000 pictures and look for grandma based on the features that it collected from the training sample. Yep.
Is this a pretty sophisticated algorithm that Google?
It used to be, okay, that used to be AI or artificial intelligence, but things that we can do relatively well with computers are no longer AI. So AI is kind of like cutting edge stuff that we want computers to be able to do with competency, but we are not quite there yet. So facial recognition, which is what that is, was a topic in AI. It is no longer a topic in AI because now we know exactly how to do it. Yep.
A follow up to that question: people who change facial, like guys with beards and shaving, and or girls with long hair, color hair. Does this program recognize that too?
I do not know. I don't know exactly how it extracts the features. Yep.
It's similar to Connect in that it builds a wireframe of that particular facial structure and then compares that wireframe to other faces.
Okay.
Like that's the basics.
Well, the question is, what does it use for the wireframe? Because certain features of our face, cannot easily be changed, depending on whether we have beard or not, long hair or short hair. Like the placement of your eyes, the shape of your eyes relative to your eyebrows and nose. Those are the features where it is really hard to change, just by using simple disguise. So I don't know. I don't know for sure. But I was digressing because of the McDonald's example, right? Because how are they going to enforce 1 per customer per day, right? It's like, okay, how many McDonald's do we have? I actually counted at one point or another. I found out that there are more churches